Today on day 4, we're going to continue our trek into congruent triangles, and we're going to add something to it called CPCTC. So essentially what CPCTC tells us is that once triangles have been congruent, then all of their corresponding parts are congruent as well. If we know two triangles to be congruent, we can then use those corresponding congruent pieces to prove that lines are parallel, to prove that we have angle bisectors or segment bisectors, or to bounce off and prove other triangles to be congruent as well. So, in a proof, the statement, corresponding parts of congruent triangles are congruent, can be abbreviated with CPCTC. Now, you will probably be asked to write out what CPCTC means at some point, so just kind of be aware of that. But as far as listing it in a proof, we're just going to focus on the letters CPCTC. Corresponding parts of congruent triangles are congruent. So what we're going to try to find here, we're going to prove some triangles congruent and then use that information to prove other things. So if we take a look here, we want to prove that BC is congruent to AD. So here's BC and AD. And when I look at these two triangles, I can tell that they share AC. So I know that triangle ABC is congruent to triangle ADC by side angle side congruence. And then our next step would be to say that BC is congruent to AD because corresponding parts of congruent triangles are congruent. We are trying to prove that angle TSU is congruent to angle VSU, and same thing here. So if I look at my diagram, I can see that my triangle TUS is congruent to triangle VUS by angle side. So our next step would be to say that angle TSU is congruent to angle VSU because corresponding parts of congruent triangles are congruent. We're going to use CPCTC most of the time right after we've proven two triangles to be congruent. So if I look at this last example here on number 3, I know that they share this reflexive piece down the middle. So be careful with how we name our triangles. If I have triangle ABD, it is going to be congruent to triangle CDB by side congruence. And we're looking at angle ADB and angle CBD. And once I know my triangles are congruent, I know that those two angles are congruent. Angle ADB is congruent to angle CBD because corresponding parts of congruent triangles are congruent. Now you can tell from this that once I prove some angles congruent, I could even take it a step further and prove that I have some parallel lines in both directions, in which case we use that converse. If alternate interior angles are congruent, then lines are parallel. So if I want to prove that PR is congruent to QS, here is PR and QS. I'm going to look at these two triangles. I see that if I take these two triangles apart, so here is PSR and QSR. Close enough. I'm going to bring this over here. So here is QRS. Here is PSR. And this piece, I'm going to move back over here. We can tell from our angle markings that angle P is congruent to angle Q. and that I have these little pieces down here that are also congruent. So down here at the bottom and down here at the bottom. What that tells us is that I have a pair of angles that are congruent down here at the base of that isosceles triangle. So angle R is congruent to angle S, and you'll notice that both of these triangles share SR. So these triangles are congruent by angle side. So then PR would be congruent to QS because corresponding parts of congruent triangles are congruent. All right, let's do a couple of proofs here. We're going to complete our proof. I have that XY is congruent to WX is given to us. And I also have that XZ bisects angle YXW. So YXW is this angle up here at the top, and if it is being bisected, then what that tells us is that these two angles are congruent. You can number those, or you can just follow what the name is given in your proof. So those two angles are congruent because they are being bisected. So definition of an angle bisector. Because those two angles are congruent, they are being bisected. Notice here it moves into XZ is congruent to XZ. So it's looking at this big reflexive piece right down the middle. So reflexive property of congruence. And looking back at our statement here, we are trying to prove that YZ is congruent to WZ. So what we're looking at here is the left half and the right half. We can essentially ignore that connector between Y and W. And by looking at what we have here, I know that the left half, YXZ, is congruent to the right half, WXZ, by side, angle, side congruence. And if those two triangles are congruent, then YZ and WZ are congruent because corresponding parts of congruent triangles are congruent. So we're looking to find some triangles that are congruent, and then we're going to use the fact that they're congruent to prove other things to be true. So let's start here with a two-column proof. These R's are angles. So angle D is congruent to angle C, and AB is congruent to BE. Angle D congruent to angle C, and AB is congruent to EB. Those are given to us. And remember those three things that we look for. We look for reflexive pieces, which I don't have any. The second thing we always try to look for are vertical angles. So here I have angle B in the middle, but remember we can't call it B, so I'm going to number them 1 and 2 in the bow tie. So angle 1 is congruent to angle 2 because we know that vertical angles are congruent. So if we look at our setup here, I have a set of angles, I have a set of sides, and then I have another set of angles. Our question is, where is the side? Is our side directly between the two angles? In this case, it is not, so our triangles are congruent by angle side congruent. So let's name those triangles. If I do triangle ADB, it is going to be congruent to triangle E. Let me back up and put that little triangle in there. Triangle ECB, and there's our angle side. Now our goal here was to prove that DB is congruent to CB, which I can do now. DB is congruent to CB because if my triangles are congruent, their corresponding parts are as well. CPCTC. One other thing that you might see, instead of asking that these are congruent, maybe it says prove that B is the midpoint. of DC, in which case our next line would be that, and we would say definition of midpoint. So there are other things that we can do other than just prove things to be congruent. We're going to use those congruent pieces to then work other things. So here's our second proof. It tells us that MQ is parallel to TN, and MQ is congruent to TN. So I've got those two things marked. They are parallel and they are congruent. So now our idea here is to prove that MN is congruent to TQ. So I need to prove my triangle's congruent first. Let's go through our checklist. I don't have any vertical angles. I do have a reflexive piece down the middle. So MT is congruent to MT. Reflexive property of congruence. And based off of my parallel lines, which will lead us to some congruent angles, I know that if I number these, angle 1 and angle 2, those two angles are congruent to each other. So you can either name them QMT and NTM, or we can just follow with angle 1 congruent to angle 2, because if lines are parallel, alternate interior angles are congruent, which then gives us enough info to say that our triangles are congruent. So if I do triangle MNT, I'm going to have to do QTM. Let's see. MNT. QTM. All right. And number 4 is our side angle side congruence. These two need to flip. That's what I had off. So this will be NMT. There we go. All right. And the last set is our two pieces that are congruent. So MN is congruent to TQ because corresponding parts of congruent triangles are congruent. Now let's see if we can recognize some of these overlapping triangles. Overlapping triangles are triangles that share either a side or an angle. These parts are usually used to prove the two triangles congruent, and we'll use the reflexive property to do that. So what triangles are overlapping? What side do they share or angle? Are they congruent, and why? So we're looking for pieces here. Sometimes it's easiest to tear these two apart. In this case, it's a little bit easier to see. We have an angle and we have an angle. And if I have NG and TH that are congruent to each other, they also share this GH. And remember that if I add the same thing to both sides, our result is going to be congruent. So I have this side here that's going to be congruent to this side here, to GT, and I'll have angle, side congruence. So triangle KNH is congruent to triangle MTG, angle, side congruence. They share GH. All right, so here, sometimes it's easiest to, like I said, take these things apart. Not only do they share ED across the bottom, so AD will be congruent to EC, But also notice they share some angles at the top. Now, once we have all of this, I can also see that I have some base angles that are congruent. So that also tells me that BC and AB are congruent, which will put me with side angle side congruence. So triangle BAD is going to be congruent to triangle BCE by side angle side congruence. Now there are some other triangles in here that you could prove to be congruent, but we're just going to focus on those that are overlapping right now, not the two that are standing off out to the side. All right, so I have these two triangles, and yes, I have vertical angles here in the middle. Okay, but remember, we're looking for overlapping triangles, so I don't really care about those right now. Same thing, I know that this triangle in the middle is going to be isosceles, but knowing that these are congruent doesn't really help us. I'm looking for triangles that overlap each other. So that tells me that I'm not focused on this triangle and this triangle. What that tells me is that I'm focused on LMK, and I'm also focused on KNM. So if I pull these apart, you can see that angle L and angle N are congruent. You can also see that angle M and angle K are congruent, and they share KM down at the bottom. So this is KNM and LKM. They share that reflexive piece. Triangle LKM is congruent to triangle NMK by angle side congruence. And our last one here actually has a reflexive angle. So if I pull these two apart, again, we're looking at triangles that overlap. Here's this and this angle. I'm going to pull this down. This is ZWU and VXW. So here is V, X, and W. And notice that this angle W went with both triangles. So that tells me that triangle ZWU is congruent to triangle XWV. Notice that that reflexive angle is in the same spot in both of those by angle side congruence. Remember, if the side is not directly between your two angles, it is angle side, not angle side angle.